Hello guys, I'm Adarsh Narayan Pandey, undergraduate at BITS Pilani, Goa campus, India. So I've been working on the user dashboard project as a part of Team 23 under ESOP 2022, mentored by Sylvie and Edward. So let's get started. The outline will be something like we'll go through the introduction, the goal of the project, quick revisit to the user dashboard that we had after ESOP 2021, the user dashboard V 2.0 as I name it, the architecture of the dashboard as it stands currently, the widget discussions, and followed by the demo and deliverables achieved, and then the future plans followed by the questionnaire. So introduction. So ECMWF consists of a large user base spanning across the researchers and scholars that have data needs, and they can in turn ECMWF has a lot of applications and sub applications that cater that those data needs of the users. But till now there was no like central place to look out for the requested data. So if let's say you want to request data from 5 applications, you'll visit each application separately and look out for the status of your request and all. So to solve this issue, user dashboard was proposed as a project in 2021, which is being carried in 2022. So the goal of this project was that the follow-up of 2021 was that we had some basic architecture that allowed some apps to be connected to the dashboard. However, the need was for any app to be there as per the user's wish. So that was the main highlight of the challenge. And the goal was to move forward with integration from individual apps using simple discoverable widget API, comparable to GetCapabilities of OGC Web Services. We'll be going through all these things in the presentation, so don't worry if you don't understand some things right now. So quick run through of the application before ESOP 2022 coding phase. So this is what the application looked like. We had a nice dashboard, a chart browser, and which showed some iframe charts that could be added to the dashboard. Add widget menu bar, which shows the types of widget that could be added, and as we can see, they are kind of app specific. As of now, they were kind of app specific, and then the tabs which could present the data as little application widgets. So current status is this is how it looks like. We'll go through the tech stack first. So it's built using TypeScript language. Backend libraries and frameworks are Node.js and Express.js. Frontend, we are using React, Next, and Markdown to JSX. Database tools and libraries are MongoDB and Mongoose as a library to query the MongoDB queries. API handlers, we are using Axios, and authentication, we are using Passport.js. So the architecture. So we had to define something API that can take any kind of app from the user and render it to the dashboard depending on the fixed types that we have. For that, we needed some endpoint that will list all the widgets according to the endpoints that will be provided to us by the ECMWF web team. So this GetWidget API is the endpoint that is responsible for listing out all the available widgets that we have and that can be added to the user dashboard. The response is of the following type. We'll have name and endpoint of the request that we get, and then the widgets will be listed as kind of the data, the payload that will be rendering on the widget browser. So this is how it happens. The widget browser sends a GET request to the user dashboard backend. It in turn sends a GET request to ECMWF GetWidgets endpoints, which gives us the data to the backend, and then the data reaches the widget browser, and this is how it is rendered in the front end. Behind the scenes, what happens is when we click to the user dashboard, it creates a GET request to the particular widget API, which after extracting the title, href, name, app URL type, and all, and making a config object of it, and it passes to something which we call as a tab manager. And then tab manager is responsible for adding this to the current widgets of a particular tab. Then the tab manager on like clicking the dashboard, the tab manager according to the type of the widget calls the widget builder's build function, and which in turn calls the widget blueprint, which is just responsible for rendering the final data. So how widget blueprint works is it sends a GET request to the application endpoint, and it just like renders the UI. So we as of now have 4 different widget types, and any application falling in those 4 different widget types can be added to the dashboard, and it's not user specific. So that's like one of the biggest achievements so far. So we'll go through the widget types in brief. Table widgets are for rendering any kind of tabular data, allows that color coding according to the CSS colors based on the API response, which was not there in the previous version. And it is not specific to the application, but to the type, as I mentioned before. And this is how the API response of a table widgets is expected. We'll have some metadata, and then the final data that we want will be an array of arrays, and then the styling is also important here, because this is how we'll be rendering and applying colors and some helpful stuff. And this is how the final UI of a table widget looks like. Next, we move on to the text widgets. These are for the textual data and has the ability to process markdown tests and convert accordingly. So this is how the API response of a text widget looks like. We'll have some metadata, and then the data is that we'll have something like this, markdown or static text, and then that will be rendered like this. Now we'll have iframe widgets. So these widgets can be used by any application that wants to provide a rich user interface through a widget. And again, it's not specific to the application, but to the type. So a typical iframe widget API response should look something like this, some metadata, and then we'll have the SRC in the data, and that points to the URL of the site to be displayed as an iframe. So iframe widgets are rendered something like this. Now it's time for a quick demo. I'll just give me a confirmation if you guys can see the dashboard application.
Yes, we can see it.
Yeah, so this is how the landing page looks like. We go to the user dashboard. Yeah, I'll just remove all these and add ones to make sure you guys get the view of what's happening. Yeah, so the widget browser is the one that is responsible for listing all the available widgets. Yeah, so we have the widget browser and with the toggle functionality for applying the images. Then we'll just add some of the widgets right now. Let's go to the dashboard, and yeah, you can see the different types of widgets on the dashboard. So this is a table widget with all the styling that has been specified by the application. These are the markdown widgets, and these also have clickable links. And then the OpenIFS widget for, again, which gives us a tabular data which is color coded according to the status of the request. So that's for the demo right now. I'll switch to the presentation. Now, the deliverables that have been achieved are, like we discussed and formulated the API format for Get widgets and different application widgets. We created the widget browser, which was not there, a central place to explore and available application widgets that can be added to the dashboard. We transformed the architecture of the project from a centralized widget management tool, as we saw that we could query some widgets and add to the dashboard, to a place like to a generalized widget API, like from a central place to access data of different applications to a client application for different applications. I did a redirect button to redirect the user to a particular application for more information. I did a refresh button in appropriate widgets, added main types of application architectures, and rendered them successfully as widgets in the dashboard. Allowed a markdown-based data rendering through text widgets, enabled custom styling in table type widgets according to the application's need to give visual representation of the type of data on the dashboard. Accommodated chart widgets as iframe on the dashboard, and can render any application data as widgets on the dashboard that fall under those types. So what's next? The next phase of this coding period will focus more on adding more types of the widgets, implementing the filter functionality in the widget browser, which might include tag-based filtering and type-based filtering, code refactor, and more towards deployment, user authentication to retrieve personalized information from the widgets, and managing the state of application through user authentication context. So that's all for my presentation. If you have any question,